After over 5 years in the making, Swift 6 has finally arrived, and it brings a ton of new features and improvements. In fact, it packed so much that migrating to this new version might take you a while. But that won't stop you anyway, will it? Hey there, I'm Yakov, and this is the Swift Bird. For today's video, I reviewed and ranked the most prominent features of Swift 6. And now I'll give you my top 6 of them. Of course, my ranking is subjective, but I'll also explain how these features work and why I chose them. So I hope this video will be helpful even if you disagree with my picks. Speaking of helpful, you would really help me grow this channel if you subscribe to it. Just one more thing before we dive into the updates. This video is about Swift, and I'll mainly focus on the changes in the language itself. There's a lot of other things that arrived this year, a brand new testing framework for example. I'll have separate videos about some of them, so stay tuned. And if you're interested in something specific, let me know in the comments. Now's a good time to grab a snack and settle in, because in a second I'm starting with number 6 on my list. Chances are you've never used parameter packs in Swift. Maybe you haven't even heard of them. And I'm not gonna lie, it's not a feature that I use every day. In the last year I needed it maybe 2 or 3 times. However, parameter packs are a valuable tool when you work with generics. And especially when you need to mix different concrete types in parameters of a single function. For example, imagine you've got a method which handles server requests as a single batch. Each request has some payload, which means their types aren't the same. Before parameter packs arrived in Swift 5.9, scenarios like this required you to either use type erasure or write overloads for different variants. 1 parameter, 2 parameters, 3 parameters, and so on. As you can imagine, type erasure loses valuable information, and declaring separate functions limits the total number of parameters, because you can't have a million of them. I mean, you can, but you probably don't want to. Parameter packs enable your functions to accept as many parameters as you need, without erasing their types and without overloads. But when you needed to iterate over all elements in a pack, it wasn't very straightforward. Swift 6 introduces a new kind of syntax for such cases. Now you can use regular for-in loops, which means using parameter packs should require significantly less boilerplate. Besides, pack expansion now supports closures, which enables yet another use case. In this update, parameter packs become a more versatile tool that can now be used in new contexts. I guess it's time to pay closer attention to this language construct. In the description, I'll link to some blog posts and WWDC sessions. They help me better understand parameter packs. And if you want to see an in-depth video about them here, let me know in the comments. Now let's move on to number 5. At 5th place, we've got an update to another feature that was introduced a year ago in Swift 5.9. This feature is non-copyable types, and once again, it's not something you see very often in your typical app. That's my experience at least. Nevertheless, non-copyable types are a powerful tool, which adds another line of defense against data inconsistency. As you know, in Swift you can choose between value and reference types to store data. I did a video where I explained and compared them, so I won't repeat myself. The aspect that's important right now is what happens when you copy a variable. When it's a reference type, a class for example, you just get another pointer to the same object. And if you want an independent copy, it's up to you to implement a mechanism for that. But value types are different. They are copied, so your second variable will have an equal but separate value. In most cases, that's how you want it to be. But sometimes you may want to limit this. Imagine, for example, that you're working with an object that represents an order in your coffee shop. This object has a property which indicates whether this order is complete. You need to be careful when you copy the order object, because the changes won't be synced between the copies. You don't want to make the same latte over and over again, right? Swift 5.9 allowed you to suppress the copyable conformance. This conformance is automatically synthesized for all value types and protocols. When you conform the struct to ~copyable, or should I say unconform, maybe deconform, well, in that case the struct is no longer copied. Instead, the single object is transferred between different owners, and when a copy is created, the original is consumed. If you then try to use the original property, the compiler won't be happy. Oh, and by the way, if you ever seen Rust code, this kinda rings a bell, doesn't it? borrowing, consuming, so on. But I digress. Before Swift 6, non-copyable types were limited to non-generic value types. In other words, you could mark a structure or enumeration as non-copyable, but you couldn't do the same with protocols or generics. Moreover, since all protocols were copyable, you couldn't conform a non-copyable struct to them. All that sorta limited the application of this entire concept. Swift 6 addresses this concern. In my coffee shop example, I can for instance create a separate protocol. This protocol says that any type with the state property should not be copyable. This way I can, or should be able to, prevent inconsistencies in the data. However, it's not that simple. There's one important nuance I'd like to emphasize, and it's especially important if you're going to use non-copyable types in your real projects. In my opinion, this whole non-copyable terminology is a bit misleading, or at least confusing. You see, when you add the copyable conformance, it doesn't mean that the type can be copied. You only remove the guarantee that it can. As a result, the copyability status becomes unknown, but not negative. In practice, if you want to make your struct non-copyable, it's not enough to conform it to a non-copyable protocol. Such protocols only allow non-copyable types to conform to them, but they don't prevent copyable types from conforming too. In that case, you have to mark the struct itself non-copyable. I know, it's not the most intuitive thing. I tried to explain it in simple terms, but I could be getting something wrong here myself. I'd appreciate your corrections if you have any. And I'll probably do a separate video about explicit ownership in Swift, so if you have any questions about it, post them in the comments too. Number 4 on my list is new synchronization primitives. You may not use tools like locks, mutexes, or atomics in your day-to-day work, but you probably heard about them at some point. This year we've got a whole new framework written in Swift, which provides some of these mechanisms. The most interesting ones are atomic and mutex. I won't stop here for too long, because the principle behind them stays the same, no matter which language they use. I'll only mention that both use the syntax which is as close to vanilla Swift as possible. For instance, the atomic struct works through generics, which means accessing the rep data is very straightforward. Both atomic and mutex require the properties to be constants, so you're protected against unintended changes even further. And now is number 3. Here I have a brand new compiler mode in Swift. But that's not the mode you might be thinking about. To that mode I'll get in a minute. Right now I'm talking about embedded Swift, which is basically a stripped down version of the language, which is specifically designed to run on low power devices. Embedded Swift supports most, but not all features of Swift. For instance, you can't use reflection APIs, meta types, and the existential any. The last part is probably the biggest practical restriction of embedded Swift, because every time you use some protocol as a concrete value, as opposed to a generic constraint, you're explicitly using the existential any. When you write code for embedded Swift, you'd have to find a different way to inject dependencies and do other stuff for which you typically use existential types. The idea behind these restrictions comes down to unloading the runtime. The compiler wants to perform as many checks as possible during compilation, so the scarce resources aren't wasted. Otherwise, embedded Swift is very similar to the full version of the language. If you want to use it, you shouldn't have too much trouble. Now let's talk about something big. I'd say it is the single most important change that arrives in Swift 6. And that is the new concurrency model. It enables data isolation and guarantees data race safety by default. Previously, you had to opt into complete concurrency checking for that. And even then, you were only warned about potential issues. The compiler didn't really force you to fix them. This all changes in the Swift 6 mode. Now your code won't build at all if the compiler detects problems with concurrency. Swift 6 is supposed to be smarter in detecting potential races when compared to version 5.10. But in my own projects, I didn't see that much of a difference. Maybe you've seen some turmoil on the internet about using Swift 6. People complain about how many errors they get and how much of a refactoring they have to do just to fix them. One good news is that Swift 6 is not all or nothing. You can adopt it module by module. Apple recommends that you start from the top of your hierarchy. Fix the app target first, and then deal with its dependencies. In my projects, I didn't see any specific benefits to this approach, but I can't refute it either. Another good news is that the Swift 6 mode is only one of the modes available in the Swift 6 compiler. Yeah, I know, it's a little confusing. The important point is that you can upgrade to Xcode 16 right now, but continue using Swift 5 and even Swift 4. Finally, the compiler is not omniscient, meaning it can't know everything about your codebase. So as a last resort, you've got this magic expression which lets you ignore concurrency errors, in some places, not everywhere. But just as with other unsafe keywords, unowned unsafe for example, you better know what you're doing. Don't abuse this thing, because you'll lose the helpful insights and can easily make mistakes. When you see that you're gonna need too many exemptions like this, consider sticking with Swift 5 for now. You can fix those issues one by one. Despite all the fanfare about data isolation in Swift 6, I didn't rank in first on my list. Why is that? What could be a more welcome improvement than freedom from data races? In my opinion, it is type throws. In the many years I've been working with Swift, one thing that always bothered me was the untyped nature of errors thrown from functions. I can imagine that, just as many other things in Swift, this particular quirk was inherited from Objective-C. In Objective-C, errors are instances of either NS error itself or some subclass of it. Swift, on the other hand, allows any type to be used as an error, as long as it conforms to the error protocol. Nevertheless, when a Swift function actually throws an error, its type gets erased, and all you have to work with is the localized error property. Sometimes you can breach the object to NS error and find extra detail in its properties, but that's not guaranteed. In my opinion, the way errors worked in Swift kinda violated the fundamental principles of the language. Swift strongly prefers value types whenever possible, and it strives to perform safety checks at compile time. Throwing errors from Swift functions always use dynamic allocation, and static checks just didn't work with them. If you wanted to have a concrete error type, you could use the result enum, of course. Result was introduced in Swift 5 to let you specify concrete types for both outcomes, success and failure. The problem is, result can be thrown from a function, because it's not an error technically. Instead, you had to use result as a normal return type. But as you can imagine, an API where some methods throw while others return a result doesn't look very nice, or consistent for that sake. Swift 6 finally fixes this problem. Now, when you declare a thrown function, you can specify a concrete error type. Best of all, when you catch this function's error, it also has a concrete type in the catch block. As for your existing code, it'll continue to work just as before. Throws without a type is equivalent to the existential any error, while the absence of the throws keyword is the same as an error of the never type. So, strictly speaking, in Swift 6 every function becomes throwing. But that, of course, is just implementation details, it's not really important. I'd say type throws are most helpful when you use them internally, within a single module. In that case, absolutely feel free to use your custom error type right in the method signature. Of course, you can declare a function with type throws as public, but in that case, the error type also has to be exposed publicly. That's not always a good idea, because from this point forward, it's not gonna be as easy to refactor the code, add, remove, or rename error cases, for example. As a compromise, you can use a common yet more specialized type than the base error protocol. One example is localized error, which comes from Foundation. It lets you provide more details about what went wrong, but it doesn't require you to expose the internals. Nonetheless, I believe the addition of statically typed throws is a big win for code clarity and conciseness. It makes your interfaces more expressive and lets you skip redundant typecasting in many places. And that basically wraps up my top 6 updates of Swift 6. But there's one more thing I want to cover in this video. It is how you migrate your codebase, which may have many thousands of lines at this point. And the best news here is that it's easier than it may seem at first. That's because Swift 6 is offered as a separate language mode, and unless you opt into it, no extra rules will apply to your code. Moreover, all features except data isolation don't require you to switch to this mode. You can take advantage of type throws, parameter packs, and everything else while still using Swift 5, and without having to fix concurrency issues just now. In other words, you're not in a rush. And when it comes to data isolation, you're offered a step-by-step approach. First, you enable targeted concurrency checking in project settings. Then you fix the warnings. At this point, they're just warnings. After that, you enable complete check-in, and once again fix the warnings. When there's no more left, you finally enable the Swift 6 language mode. Keep in mind that from now on, concurrency violations will result in build errors. Overall, there's nothing you can't pull off. I'll give you an example. It took me a day or two to fix about 90 concurrency warnings I received in my app. It's like 6 years old, and I've been using it for practice since the beginning of my career. You can imagine that its code quality is far from ideal. Nevertheless, the time it took me to prepare for Swift 6 was more or less what I expected. Of course, all this also works in Swift packages, even though it's a bit less straightforward. To enable strict concurrency check-in, you add a compiler setting to your package's declaration. And when you're ready to completely switch to Swift 6, you change the tools version at the top of the file. In the description, I'll leave a couple links which give you in-depth guidance on the upgrade process. And now's the time for a summary. In my opinion, Swift 6 brings a number of very helpful improvements, which allow you to write cleaner and more expressive code. Personally, I'm most excited about type throws, but beyond that, this Swift version also ships a few advanced features. Complete data isolation, low-level concurrency tools, non-copyable types, and even more. These features may take you some time to adopt in your codebase, but you don't have to hurry. Thanks for watching. If you like this video, make sure to give it a thumbs up and subscribe to the Swiftbird. This way you're helping other people to discover this channel. Let me know in the comments which Swift 6 update you are most looking forward to. And if you're interested to learn about some of them in detail, you can write about that too. I'll see you later with more tech stuff. Until then, make your Swift fly.